they did an experiment where they took two spherical capacitors, and in those when they built up their setup, they like charged one of the spherical capacitors so that it arc flashed, and the arc flash transmitted across to the other capacitor, and they had antennas picking up on both sides, measuring to see what the time delay was. They were 1.5 meters apart, so there should have been a 5 nanosecond time delay based on the speed of light. But what they did is they made sure that the capacitors were in the near field, which means that the distance between them was less than the wavelength of the radio pulse that got emitted by the arc flash. So the arc flash, they were measuring all the radio pulses that were 2 megahertz and below in frequency, so like 150 meter wavelength and bigger. So they were in like the very near field, and at that distance, basically they couldn't measure any finite time delay between the signal received on the antenna on the arc flash side and the signal received on the receiver antenna on the other side. There should have been a minimum 5 nanosecond time delay based on the speed of light, and there was zero. They're perfectly synced up on the oscilloscope. They're using one oscilloscope, the two channels, one for each side, and so it demonstrated that basically Maxwell's displacement current was either non-local or extremely superluminal, in accordance with like Maxwell's original theory. And also it demonstrated that it was longitudinal components that were carrying this this voltage, which is part of the Maxwellian electric field equation. It's scalar potential combined with vector A change in time. Scalar potential is just voltage, meaning that whatever kind of wave traveled had to be a longitudinal wave, and since it's a longitudinal wave, that necessitates a physical medium, unlike a transverse wave. So it proves that there's a medium, it proves that there's longitudinal waves, and it proves that in the near field range of a capacitor, of two capacitors, you can transmit information with no measurable time delay down to the sensitivity of the instrument.
So like instant?
As far as the resolution of the instrument was concerned, it was instant. It might not necessarily be truly instant, but it's like so fast that they couldn't tell.
I remember you put me on that superluminal stuff the other week.
Foundational to your existence.
What's that?
We still got knuckleheads who can't accept that. Well, the ones who aren't spinning.
Yeah, I mean, it's highly superluminal, right? But it's it makes sense mathematically, because if you look in the paper, they show a graph showing the trace between the ratio between distance away and speed of light in units of C compared to distance away relative to the wavelength, and immediately upon leaving, the source, it's like a vertical asymptote on the graph, and then it exponentially curves down and turns into a flat line, which the flat line is representative of the speed of light, and the vertical asymptote is representative of infinity. And so as it gets further away from the source, the speed of the propagation goes from near infinite towards C. Once it reaches the same distance as the wavelength, it travels at C from there.
I was going to ask you to break that down back from the beginning, but just there in the end, you're saying the infinite is at the first part?
Yeah, like at the source, right where the source is of the arc flash, it's the speed at that point of the emission is near infinite, and it tapers off as it approaches a distance away that's equal to the wavelength. And once it reaches a distance equal to the wavelength, then it's at C.
All right, let me pick your brain for this, because man, boy, you are up on some stuff. I'm sure you're familiar with the 30,000 frames per second camera imaging, or whatever it is, 30,000 frames a second.
They got way more than that, dude. They got like millions now.
Okay, so they have millions. How do these match up now? Like, is this million frames a second enough to do anything? How many million per second would they need to maybe start even seeing more? Like, what are your thoughts on that? If not,
I don't know how many frames. What do you mean see it? You can't see electricity in the air, voltage in the air. It's not a camera.
Okay, I got you, but maybe there's some.
It's not light. It's not light that they're viewing. It's radio waves.
Sure, but maybe like in the future, there'll
Radio
be
impulses.
there'll be ways to have that in, or we could put some. There might be a different lensing technique or different X-rays or something. I don't know. I'm just curious. Like, or they have another medium. Like, if it's
I mean, maybe they could use some kind of radio telescope to look at it from the side or something, and view it in like the radio band region of the pulses that get emitted. But that would be interesting.
I have no problem.
What is it you're trying to ask, though?
I'm just trying to ask about anything in the industry that could make progress on this or that is happening. I mean, I don't know nothing.
Oh, okay, that's a wide question. The real issue is the history behind it. Progress is not going to be made if people don't want to make progress on a large percentage of the population. Most of these people can't even get their head around what's being talked about.
They want it. There's plenty of old heads and students who aren't going to feel bound by Einstein's.
Not enough.
They're going to do. They're going to.
Yeah, but not enough to move industry. It's not that it's not happening,
Look,
but your question was more like a societal question than a physics question.
Yeah, just like how like I could be like, oh, there's compartmentalization, there's oppression, there's corruption, like, and there's people like that would be scared to ever try to maybe go against mainstream. I'm sure though there's plenty of scientists, young and old, that still want to break the rules. I mean, that aren't scared.
Have you spoken to quote unquote scientists on a regular basis?
Oh, I got it. I know there's plenty of them that are dense or unfair or scared or whatever. I'm sure, but both things can be true, right? There can be a
the percentages are really low.
Okay, all right.
So, and how long? Who's that Professor Piezo?
Man, we need 2 people. We don't need. You know what I mean? I think there's probably more than 2.
Yeah, but it's a whole lot of study. You got what? Dollard and forget the other guy's name. Lindemann. So there's other people. Those are the only 2 names I can remember. Peter Lindemann and Dollard. They're working on stuff back. I could repost a video, but this work has been strategically hampered.
Well, it's just not accepted in the mainstream model of physics. Like, for example, ChatGPT refused to believe that this experiment was like valid or properly conducted, or that the actual data from it was actually true data. Like, it just refused. It was like, nope, that contradicts the model of physics. And it's like, yeah, that's the point. Nope.
Yeah, it's filtering its processing through consensus. You're never going to get a decent answer out of that.
Google did a good job, though. They were like, extraordinary claims require extraordinary evidence, so the scientific community still hasn't accepted it. This is a preprint. We await to see further replication. But if it were true, it would mean an entire overturning of the whole mainstream physics electrodynamics model. It would prove longitudinal waves and also prove a medium necessary for the propagation thereof. So, like, Google had a good answer. ChatGPT is like super propagandized.
Mm-hmm.
I honestly need to get rid of GPT and get a Gemini account probably, but
that's
no, what you need to do is get one that runs offline and then train it. Well, that's my opinion. You don't need to do that, but I think that would be the better way. Depends how much resources you can bring to bear, though, whether you're willing to do that.
I don't know. You want to let its bias come out, kind of, don't you? I don't know, because if you curate it, like, you want to let its bias come out, like, and show the standard open information bias. Because if you curate it, I don't know, you know what I mean? Like, you'll get a false wouldn't you be worried about a false positive if you curate it, you know?
I mean, if you
It's not
don't
about
trust
curating,
yourself
bro.
that much,
Yeah, I'm not relying on it to do all the thinking for me. I was just like using it to see if like it could give a fair shake to the data, and that's the
Yeah,
point. Like,
I was responding to him saying train it though.
oh,
Yeah, my bad. So
well,
I'm
no,
sorry.
the ones that you can get that run offline are maybe not going to be as capable, but you can put it through training because they have the capability. They're just not default. But I mean, I don't see unless you're like skin broke. I don't see the issue with and you're that
they
much
have
into
uncensored
research.
ones. You can get like uncensored.ai or whatever, or unbanned.ai, whatever they're called. There's different ones. But they like don't propagandize you. They'll actually like think and accept conclusions that aren't like consensus opinions if the logic leads them there.
Can I rehash with you? What should I say, man? What do you like to be called, sir? JC. JC? Is that what they?
So
JC. Can I rehash with you when you shared the knowledge of superluminal stuff with me, which I was completely naive to. I think if I parroted it correctly, the Steelman for the mainstream was something like not usable information or something.
yeah, no information can be sent. And the other thing that I was talking about with the coaxial cables, the photonic crystals, Hot-Chain Poirier 2003, their rescue device was no useful information can be sent. That's what they said in the paper. No useful information, because obviously turning the detector on is like energy, right? You don't have zero energy turning a detector from 0 to 1. It's positive amounts of energy. So they
Yeah,
said
but
no useful information.
that's like, is that really the steelest of steelman for them? Because that seems so asinine. You would think the community would be jumping up and down and go, look, a signal
Well,
faster than light. Like
yeah,
a signal is information.
it's
You know,
because
like I don't.
usually it's because in wave dynamics, the group velocity is accepted as the part that carries the energy and carries the information. The phase velocity is just individual points along different wavefronts. But the group velocity is what indicates where the information, where the energy is carried, right? And so when they show superluminal group velocity, it's like, oh, this appears to violate causality. But really, it's just a matter of definition, because at superluminal speeds, no useful information can be sent. Like, that can include the word useful, because obviously, if the group velocity is turning on the detector, which is what does it, if it gets turned on, it's the group doing it, then clearly it means that it got there when it got there with velocity equals distance over time. So it's just a rescue device. And in this case, with the freaking capacitor thing, I mean, it's like they're super cooked, because I mean, you have a radio wave being emitted and traveling to an antenna, right? Like from one side to the other, it's a radio wave across the air, and there's literally zero perceivable time delay down to the sensitivity of the instrument. So it's near instantaneous in the near field region they have it in, and clearly an antenna responds to radio waves. It doesn't respond to nothingness. It doesn't respond to not energy reaching it. Like, it doesn't respond until it gets touched by the radio wave. So
Who champions this? Are there champion figures of this in academia that are on your side of it?
superluminal stuff. I mean,
No,
probably the people who write these papers. Oh,
The people that do the tests, probably. I mean, I couldn't even Piezo the day after you guys did that when Witsit was here and all you guys. The next day in the morning, I couldn't even get these guys to admit that anything was actually moving faster than the speed of light. They said
and I
nothing's
was going
moving
to say,
faster than the speed of light.
I'm like, Dev, you had a calm conversation with Zanuck about this? I should take out the word
Yeah, but
calm.
that's because they're liars, bro.
Nah,
Not
you give them
because
too
it's
much
not.
credit now.
It's not
These guys are knuckleheads. They don't even
exactly.
realize that C is as a result of the medium rather than the other way around. They talk about C as if it's like a fundamental to the universe. But that's not how they even extracted the number in the first place. Their heads are inside out.
Well, C is just the speed limit of the transverse component of electromagnetic wave propagation, which is the default component that we always measure every day. Right? It's the speed limit is C. But in the particular case of the capacitor experiment, it's significant because the thing inside of capacitors, like the current inside a capacitor, is not an electron current. Because if you think about what a capacitor is, it's literally a gap between two plates, right? So there's
Right.
just there's empty space
Insulator
in between.
conductor.
Yeah, electrons do not flow across a gap, right? That's literally by definition an open circuit. And so it's not electron current. It's what Maxwell called his Maxwell's displacement current. That's what travels between the plates of a capacitor. It's not actual electrons. They say it's displacement current. It's like a unique thing.
So what does
And
that mean? They don't travel along they disappear and reappear across. Like, because I look,
no, they say they
I'm sorry,
they
I'm so stupid. Well,
yeah. I'll
okay,
explain it.
I can hold.
Forces you to accept the medium that everyone wants to deny if you use your head.
Yeah, they say that
Okay.
the field in between the plates acts in the place of a current and has the same effects as a current and drives the electrons to move from one plate to the other backwards through the circuit, not actually through the gap between.
But okay. So let me ask them this. I can study this too. If I keep coming up with stuff that's like stupid questions, just be like, yo, study them. But what about the plasma stuff in vacuums? Don't they have like vacuum bulbs and it's moving between? Maybe it's not a capacitor, but don't they have plasma jumping from one empty space from one to another?
Well, I mean, plasma is defined as ionized gas. However,
Oh,
in vacuum dynamics, there are unique things like there's such a thing as spontaneous vacuum ionization and vacuum breakdown. So you can actually have if you conduct over a megavolt, it's like 1.02 or 1.03 megavolt or something like that, 1.04 or something like that, a little over a million volts. If you conduct over a million volts through a vacuum, you can actually get what is called vacuum breakdown or spontaneous vacuum ionization, which is where
everything,
electrons will basically spawn out of the vacuum as well as like gamma rays and radio waves.
and then
So
escape, or because
it's called vacuum polarization as well. It's where you polarize the substance of the vacuum because in quantum mechanics and quantum field theory, the vacuum's not truly empty. It's filled at every place in the universe. It's like it's filled everywhere with these fields, right? And
right. Well,
so
so Mhm.
they treat the fields as having real substance when it comes to things like polarization because you can't polarize something that's not a substrate, right? Like the
right. I guess
polarization is a
right.
material thing.
And then would this be like a fair dummy breakdown to where we're saying like you ionize the whole vacuum, then nothing there, but we're like, oh, there's something in there, the current, but that stuff is like all to itself, and then the other area around, which was a vacuum and still it is, I guess, that part, like you can still see the main stuff in its area. Like when I asked the plasma question, you're like, well, that's just ionized. Yeah, some gas is in the little bulb, but don't they can like control the jet of the gas or just let it, you know what I mean? And then there is still supposedly vacuum, like you're saying, a nothing medium, what they want to be nothing medium around it, right?
I mean,
It's just
it shows that there has to be a medium, in my opinion, inside the vacuum, because otherwise, what's being polarized? You can't polarize abstract like fields. Fields
but
aren't supposed to be truly, physically, literally real material. They're supposed to be like abstractions.
But wouldn't it be like some of the other stuff that's in there, like even if it's just energy, some electricity, like wouldn't that be? And like, because the ionized, like you said, the ionization is just like the trading, going to a less or extra electron, right? And there's like things sharing that or something.
It's well, when gas is ionized, the electrons jump in their orbital states. It's like a higher phase of matter, but
They don't
there's
lose
not.
or gain one. Like they
Um,
just gain an orbit.
no,
I thought they gain
it's
charge,
the
and then
electrons that would be acquiring a charge. So I mean, like you
charge.
can yeah, I mean you can acquire charge on gases, right? Like when they fluoresce and stuff. But um, like also when you charge up gases with enough energy, right? Like so that the electrons jump in their orbital states. That's also a means of ionization.
Okay. Okay. So it's just the charge changes.
Well, the charge, I mean, if you have a net charge on it, it's going to have an extra proton or have an extra electron or a deficit electron, like for a positive or negative charge. That's what charge is. It's like electron number
Right.
relative
So
to
not the
neutral.
orbital. When the orbital changes, that still can ionize, but it's not the charge difference. It's just like a wavelength difference or something. Or what?
If you're going to bring
One
this
second.
stuff up, then,
I need
then
to
you're going to
study.
want to study Thomson's work on the electron.
Okay.
Because many of the ideas expressed about electrons nowadays are not according to the guy who actually coined the term in the first place and the work that he did. So you need to view the whole subject through the old school guys' minds and words. Otherwise, you're going to get confused.
Okay. Thompson.
J.J. Thomson. Don't ask me what the J's stand for. Okay, Joseph John. There you go.
James Jacob. Must be James Jacob. It better be.
Nice. Joseph
By
John.
the way, I guess just to clarify, ions. So, like when we talk about ionization, an ion is literally like a charged particle, right? So when we talk about like ionization, that's when a charge is acquired by a molecule. Like it gains a charge, right? Whether that be positive or negative, but because that's what an ion is, right? And ions are usually, depending on what nomenclature you're using, like a lot of times people will talk about ions as being positive because electrons is like a specific word used for negative, but technically an ion can be either charge.
Yeah, it can go Elion or Anon or positive.
Yeah, anions and cations. Yeah. I'm more of an electricity guy than I am a chemistry guy. But I mean, just talking about ionization, it is when something becomes ionized, which is charge related. So I guess me saying orbitals jumping isn't really accurate because I guess it would actually require a charge because that's what an ion is. But orbitals is like when an excitation happens, like atoms become excited because their electrons jump to a higher orbital level, and this means that they have more potential energy inside of them that can be released. This is like the photoelectric effect or the Compton effect, things like that, where they release light. So that's how fluorescence happens, which is a product of ionization, but it's not actually ionization itself. So usually, when you ionize a gas, right, a lot of gases will fluoresce, which is because as they gain charge, they also gain their orbitals also jump to the higher orbitals, and that energy ends up getting released in the form of photons. So, but that's not technically what ionization is. It's just related. Ionization is charge.
Okay. But yeah.
But they usually both happen. Like in a lot of cases, they both happen together. It's like you get like the noble gases, especially like will fluoresce, like xenon and argon, or sorry, xenon and neon and different gases.
Right. Well, whatever. Sorry again.
Helium and neon. I mean,
Whatever definition you want to put on the thing, it's like they're talking the thing you mentioned about spontaneous vacuum ionization, something vacuum ionization, like either one. It's like something's there, or something that was going between is taking a look around there now. You know what I'm saying? Um,
yeah.
like what you can't have either of those words or either of those phenomena we was talking about if nothing is there. I gotta look at this. How vacuum?
Yeah, you shouldn't be able to have that. It's like really super counterintuitive, right? This is where they get into like virtual fields and virtual particles everywhere, popping in and out of existence in the vacuum at all times, everywhere in the universe. It's like actually absurd when you think about it that they had to go that far. It's because they didn't know about it. They didn't know about all that stuff when they first came out with the theory, and then later they found out that stuff happened. So they had to find a way to like attach it to the theory to maintain the theory. So they're like, oh well, it must just be the virtual fields. Right, because we definitely know that there's not any medium because the Michelson-Morley experiment. Like that's what they say. Everything, literally, bro, everything goes back to Michelson-Morley. It's actually kind of wild when you look into it. like how important that experiment was, and a lot of people don't even know about it very well. They just learn there was an experiment they did in the 1800s that disproved the ether because they couldn't measure Earth's velocity through it, so it meant that there was no ether. Like that's all you learn. I mean, I've taken the physics classes for waves and optics and special relativity and stuff, and that's as far as we went into it, right?
And then they teach you the more sensitive instrument is getting the more precise number about it now, and the Wild Wild West. Ride 'em, cowboy. I want to see the Steelmans of the super aluminum. It's the David Copperfield trick. That's what it is. All right, thank you, JC, man. I appreciate you, man. Hope
No worries, bro.
Did y'all see that? Speaking of plasma, did y'all see the comet lost its tail?
The one that's supposed to be behind the sun or whatever.
Oh, it's out from behind the sun, and there was a House representative that had NASA release some photos. The third time, I think they were JWST photos of 3I Atlas. Yeah, and now it doesn't have a tail, I guess. I'm here to be called stupid, so anytime.
I don't keep up with all the astronomy stuff, dude. I hear about it and look at it for 2 seconds, and astronomy's gay, in my opinion. Most of it. It's not all gay,
It's
but
plasma, man.
all the space stuff is gay.
When I can't buy that they're actually going where they say they're going, yeah, I'm less interested than I would be otherwise. But still see some stuff up there, Like I don't appreciate being like the Karen, like the Karen of space footage. Like ever since you're a kid, you like some of it, and then you want more. And even at a young age, you start. For me, I started wanting more that they didn't give for all their proby probes and everything. For their handful of probes, their handful of probes, and then that same handful of probes, and the one car, one maybe car. The helicopter got there real quick too. I don't know. Just seems as a natural, honest kid, you're a disappointed customer. I don't appreciate mainstream zealots positioning that like it's a Karen position. I want some more.
Zealots is a good word. I like that word.
Yeah, yeah. Because that's who's Karen in me. That's who. If you know what I'm saying, you're just a nice, chill, like whatever. Like, but that's what I'm saying. I felt some zealot stuff yesterday, and so my bad. So I'm sure they're gonna say the comet lost its tail because it's dissipating. It's gonna go bye bye. Never seen before. Totally unexpected. breaking them up.